In this video, we're going to learn how to create polyatomic ionic compounds and formulas. You should have this chart on the top of page 84. We have these ionic compounds: sodium hydroxide, calcium sulfate, ammonium hypochlorite, aluminum thiocyanate, hydronium oxalate. We have cation symbol in charge, anion symbol in charge, and your ionic formula. Alright, so we're going to go through this really quickly. I'd first like you to go to the back of your notebook, and on this that you have glued back there in this box is this. And there's a lot of information on it, but I want you to pay attention to this part. We have these endings, and I would like you to highlight these endings. Ide is the root. You do the root of the second element, and then you add ide. These two, ite or 8, are for polyatomics. That's how you know it's a polyatomic, and that's going to come in handy here in a second. And also on this particular chart, we're going to focus in this bottom box for a second. So here it is larger. Now hopefully you've already done the note that it's in the district packet. So you don't have to memorize polyatomic ions for Collier County. First, I'd like you to notice the endings. See how they end in 8, ite. They're ending in 8 and ite. They are polyatomic ions. So they have the endings ite and 8. Except for really old ones, we have hydroxide and cyanide. They are polyatomic and they end in IDE because they're really old. Alright. I'd also, for your particular chart, was just a random chart that I picked for you. So as long as you know how to use a chart, you're fine. And sometimes they're set up different, so you just got to take a second and look at it and see how it's set up. This one is set up with all the negative ions here. It's not in alphabetical order. They're chunking based on the collection of atoms that create it. Then you have a -2 area all the way over here, -3, and then there's this +1. It's very lonely over here. There's not a lot of positive polyatomics. I'd like you to add hydronium to your list, H3O+. So we're going to use this to fill this out. If we take a look at this chart, sodium is a group 1 metal. It loses its 1 valence electron and it gets a +1 charge. That's exactly like we did a couple days ago. Hydroxide, though, it does have the ide ending, but it's one of the ones I just asked you to use. And you just go over the chart and it says OH -1. So OH minus. The positive charge and the negative charge are equal and opposite. So you just pull out the charges and write the formula. Now we're going to move on to the next one. Calcium sulfate. Calcium is a group 2 metal. It loses both valence electrons and becomes +2. Sulfate ends in ATE. So we're going to go to this chart and we have to find sulfate. So you look at the words. Here it is, sulfate. I'm just going to write SO4 2 minus. I'm going to write everything that's there. Big S for sulfur, big O for oxygen. There's 4 of them, and the whole thing has a -2 charge. Even though there's multiple things written in the anion, you're still just going to focus on the charges because they're equal and opposite, or if I add them together, it adds to 0. I'm just going to, they cancel each other out. I'm going to just pull out the charges and write the formula. The next one that I'm going to do is aluminum thiocyanate. So aluminum is a metal. It's in group 3A, so it's a 3+ charge. Thiocyanate, that ending is where what tells you to come look at this chart. So you have to scan through the list, and here it is right here, thiocyanate, SCN -1. Right. Our charges are not equal in quantity. So I have a 3+ to a 1-. So I can do 2 things. I can do least common multiple or crisscross. If I take a look at both of these, the least common multiple of 3 and 1 is 3. So what do I multiply by 3 to get 3? It's 1, so I need 1 AL. And then what do I multiply by 1 to get 3? Well, it's 3. So SCN. Now if I write the 3 like that, I'm going to have 3 nitrogens. So if I need multiple polyatomics, I have to add parentheses. That's a 3. So I'm going to add. Right.